Hello students, today we will learn about non-uniform acceleration. Non-uniform acceleration. Non-uniform acceleration. So up to now we learned uniform acceleration. Uniform acceleration. Kinematic equations for uniform acceleration, we derive v is equal to u plus at. Second one, that is v square minus u square is equal to 2as. Third equation, that is s is equal to ut plus half at square. These things we derive kinematic equations for uniform acceleration. For non-uniform accelerations, we can't use these equations. For that, we are going to derive the kinematic equations for non-uniform acceleration. So, for non-uniform acceleration, so acceleration as a function of acceleration as a function of time. Acceleration as a function of time. If you take an acceleration as a function of time, that is acceleration is directly proportional to function of time. So that is a is equal to some proportionality constant k into f of t. Let us take, let f of t is equal to t power n. So a is equal to k into t power n. Okay. This one we consider first. So now you see acceleration as a function of time. No? So acceleration we know a is equal to dv by dt. dv by dt. So instantaneous acceleration. This is instantaneous acceleration. Let this equation 1. This is equation 2. What this one? Instantaneous acceleration. Instantaneous acceleration. This is instantaneous acceleration we consider. So now a is equal to dv by dt. Compare these two equations. In the place of a, you have to substitute dv by dt. So that is dv by dt is equal to k into t power n. So send dt that side. Here we are having a time function of t power n. So dt you have to send here. So dv is equal to k into t power n dt. Okay. So now taking integration on both sides. Integration of dv from initial velocity u to final velocity v is equal to k is a constant keep outside. Integration of t power n dt. Limits lower limit is 0 to t. Time from 0 seconds to t seconds. Clear? So now integration of dv we already know. Integration of d is v. So lower limit u, upper limit v. So k into here integration of t power n. That also we know there is t power n plus 1 by n plus 1. Already we learned how to do the integration of this kind of functions. So the limit 0 to t time. So now substitute upper limit and lower limit. Upper limit minus lower limit. So that will become, this will become upper limit minus lower limit means upper limit v minus lower limit u is equal to k into upper limit t power n plus 1. This will take on n plus 1 numerator. T power n plus 1 minus t power 0 power n plus 1. 0 power n plus 1. Where 0 is lower limit, no? 0 power n plus 1. 0 power anything is 0 only comes. So now what thing we get here? V minus u is equal to k by n plus 1 into t power n plus 1. T power n plus 1. This u send that side. So v is equal to u plus k into t power n by n plus 1 into t. Into t. So now which form it is? This first equation form. V is equal to, carefully observe here, V is equal to u plus, in the place of acceleration, k into t power n by n plus 1. Acceleration. Varying acceleration changes with respect to proportional constant k and n. It depends upon proportional constant. Okay. So in the place of acceleration, we have this function, and this is the t. Okay. First form is over. So here we can write that one also. Non-uniform motion. Non-uniform acceleration. For non-uniform acceleration, first one we got v is equal to u plus k into t power n by n plus 1 into t. Okay. First equation we derived. Next, we are going to derive second equation. For second equation, acceleration is a function of displacement you take. Acceleration is a function of displacement. So I will drop this one and do pressing. So now I am going to drop this one. Take a screenshot. Okay. Now we are going to derive second kinematic equation for non-uniform acceleration motion. Non-uniform acceleration motion. Acceleration is a function of displacement. Displacement. So now acceleration is a function of displacement. So A is a proportional, directly proportional to f of x. So A is equal to k into f of x. Let f of x is equal to x power n. F of x is equal to x power n. So A is equal to k into x power n. Into x power n. So this is the acceleration is equal to some proportionality constant you have to take here. Let it be k1. Already k we took no in first equation. In the here k we did. So this proportionality constant we are taking k1. So we know that acceleration is equal to dv by dt. This we are going to write as function. Now velocity multiply and divide with dx. So this will become velocity. So is equal to dv by dx into v into v. Now this is equation 1 and this is equation 2. Substitute equation 2 in equation 1. Substitute equation 2 in equation 1. Okay. If we substitute equation 2 in equation 1, what we get? V dv by dx is equal to k1 into x power n. K1 into x power n. Dx you send that side because x function is here, no? Right hand side, send that side. V dv is equal to k1 x power n dx. Okay. Now integrating on both sides. So integrating v dv. So v becomes lower limit is u, upper limit is v. Initial velocity, final velocity. So here k1 is constant. So x power n dx here means x into x. So now integration of v or integration of x dx, that is v square by 2. Lower limit u, upper limit v. Here x power n, integration of x power n is x power n plus 1 by n plus 1. Here lower limit x naught to x. Now substitute the limits, what we get here. So upper limit minus lower limit. V square minus u square by 2 is equal to k1 by n plus 1 you take out. So here x power n plus 1 minus x naught power n plus 1. Okay. Clear? Now substitute here. So this 2 you send that side. So v square minus u square is equal to 2 into k1 by n plus 1. This difference of displacements is nothing but we can write s. So s power n plus 1. X minus x naught is nothing but difference of distances, no? So that we can write s. S we can denote as displacement. So now this we can write v square minus u square is equal to 2 into k1 s power n by n plus 1 into s. So this is in the form of v square minus u square into 2as. 2as. So now second equation also we solve. So v square minus u square is equal to 2a means k1 s power n by n plus 1 into s. Okay, clear? Note down this. Take a screenshot. Finish that. Next one. I am going to rub this one. Acceleration as a function of velocity. Further, that velocity is converted into function of time. So the acceleration as a function of velocity to time. We will convert further it into time. Okay. See, we know that velocity v is equal to, so dx by dt. V is equal to dx by dt. So dx is equal to v dt. So dx is equal to v dt. So now here carefully observe, dx is a displacement function and v is a function velocity. So this in first equation already we got velocity, in terms of acceleration. This you are going to substitute here. That we are going to substitute here. This one you have to substitute. So velocity. So acceleration is a function of velocity. So v you have to write in this form, u plus, this is acceleration in the form of this function that I am going to write here in the place of v. So dx is equal to u plus k t power n divided by n plus 1 into t into dt. Okay, clear? Any doubt? So next, dx is equal to u dt plus k t power n plus 1 by n plus 1 into dt. So now taking integration on both sides, integration of dx x naught to x is equal to here also integration of u dt tan from 0 to t plus k by n plus 1 is the constant, integration of t plus n plus 1, t power n plus 1 into dt. Here time is 0 to t. Okay, any doubt? Now integrate this function and see what we get. By integrating this, what we get, we say integration of dx, that is x. So substitute here, put the lower limit is x naught, upper limit is x. That is equal to integration of u dt. So u is constant, keep outside, integration of dt is t. So the lower limit is 0, upper limit t. Okay. Next plus k by n plus 1, integration of t power n plus 1. So that will become t power n plus 2 by n plus 2. The lower limit 0, upper limit is t. Clear? Any doubt? So now this one become upper limit minus, well, x minus x naught is equal to, here also t minus 0 plus k by n plus 1 into n plus 2 into that one, what will come? T power n plus 2 minus 0 power n plus 2. Okay. If you simplify, what we get, s minus s naught is nothing but displacement. Now s is equal to ut, here 0 goes off, plus k into t power n plus 2 t power n plus 2 by n plus 1 into n plus 2. So this one we can find in the right. S is equal to ut plus, so k into t power n by n plus 1 into n plus 2, n plus 1 into n plus 2 into t square. So this is in the form of s is equal to ut plus half at square. So half we need, no, half we need means we have to multiply with 2 and divide with 2. So half into this one into t square. So this is the acceleration which depends upon k t power n and n t and n, k t and n. Okay. So now third equation also we get for non-uniform acceleration motion. Non-uniform acceleration motion. So third kinematic equation for non-uniform acceleration motion, S is equal to ut plus half 2k t power n by n plus 1 into n plus 2 into t square. This is in the form of S is equal to ut plus half a t square, where a in the place of a, this is the varying acceleration which depends upon the proportionality constant k and n. Okay, clear? Note down this one.